I guess we're really trying to solve two problems at once. We're trying to make America energy independent, and we're also trying to solve for this problem of climate change. As we know, the way that we make our energy today, using fossil fuels, is a challenge to both of those things. So, what other options do we have? Scientists know that there are four sources of energy that physics today sort of lets us look at. There's solar energy, there's gravity, there's heat, and there's nuclear. So let's look at those. There's an enormous amount of power, 162,000 terawatts of power in solar energy. And while ever the sun is out there burning, that's going to be there. So it's essentially renewable for as long as the sun is around. Then there's gravitational energy. This is the motion of the moon spinning around the planet and the Earth orbiting around the sun. That makes the tides go up and down. It even makes the shape of the Earth just very subtly change, and that puts some heat into the system. Unfortunately, there's only about 3.5 terawatts of power in all of the energy of gravitation in all of the tides. Heat, or geothermal heat, so this is what happened when the Earth collapsed, and there was a lot of heat left over from that process, and also from the decay of radioactive nucleotides in the Earth's core. There's about 32 terawatts of power radiating out from the Earth's core all the time. That's about twice as much as humanity needs, so there's a lot of power there. Nuclear, it's a finite amount of energy. It's not a renewable energy source, but however there is an enormous amount of it. If we kept using the amount of nuclear power we do today, we've probably got a little more than 100 years using the simplest type of nuclear reactors. If we change to breeder reactors, we probably get 10,000 years or more with nuclear energy. So, what about the solar energy one? This one's worth looking at in detail because it tells us what do we have to build to make a clean energy or an energy independent grid for North America. So here's the solar flux. That 162,000 terawatts that hits out of the atmosphere, about 40,000 terawatts that bounces back out into space. A whole bunch scatters in the atmosphere close to the Earth, and even about 5,000 terawatts bounces off the oceans and the ice caps also out into space. Nevertheless, still an enormous amount hits the Earth. A lot of it hits the land masses of the Earth and heats them up. A whole bunch evaporates the water in the oceans, and some of it heats the atmosphere. So here, if you like, is the map of all of our options of renewable energies. There's 3.5 terawatts of tidal power from the motions of the planets up in the corner. There's 3 terawatts in all the waves that hit every coastline. That wave energy is driven up by wind energy. There's an enormous amount of wind energy, about 3,600 terawatts of power. And that wind energy is picked up by the heating of the atmosphere by solar energy. If you covered the entire planet with a solar cell, you could make about 85,000 terawatts of solar energy. And that's a much bigger number than the 18 terawatts that we need to drive humanity. Let's have a look at a couple of the other things. If you dammed every single river in the world, you'd probably only get around 7 terawatts of power, less than half of the power that humanity uses today. So we have to have limited expectations on hydroelectric power and its increase. Even for biofuels, that's really a product of photosynthesis. Scientists already know how much photosynthetic activity there is across the entire planet. If you took every single plant and algae and moss and photosynthetic product made on land on the planet, you'd only make about 65 terawatts of power in total. That's only 3 or 4 times what humanity uses today. Why is it important to know all of these very big numbers? Because you've got to make a lot of power for humanity, you've got to make a lot of power for North America, and you want to choose the sources that you can take it from that are the biggest so that you have the smallest impact on other aspects of the environment and our planet.